The standard curved space model of relativity works great, but it's impossible to visualize and difficult to compute. However, there's a much better equivalent model that's very simple and leads to important new insights into the relativistic universe. This talk summarizes the model. For the full theory of everything, see my book Universal Reality 2.0, which is available in a free PDF version at edgarallowen.com/reality.shtml. The model. The model is quite simple. Just take all the curves in a curved space and compress them lengthwise until they're straight and the space becomes flat. This compression crumples each of the curves along its length into a series of minute wavelets, whose amplitude is proportional to the previous curvature. The length of each straight line up and down across all its wavelets is the same as the length of the original curved line. For example, the depression in the typical rubber sheet model of gravitation would be flattened upward until the sheet was flat, but all the lines of its grid were now compressed into lines of minute wavelets. Now imagine these wavelets aren't static, but are actually hyperfine vibrations in the fabric of space itself, and set them all into motion. The result is a perfectly flat space that maintains all the original relativistic information of the original curved space, but replaces the curvature with a field of minute vibrations. Where there was curvature before, there's now an equivalent amount of intrinsic vibrational velocity in the fabric of space itself. The implications. Mathematically, this model works just like the usual curved space model, but it leads to a number of extremely important new insights. First, we can now very simply model masses as fields of intrinsic velocity in the fabric of space. This immediately gives us an explanation of how mass curved space that was completely missing from relativity. Relativity told us that mass curved space, but could never tell us why. But in this new model, masses actually are fields of velocity density in space, and the resulting velocity densified space acts just like the old curved space model of relativity, but now we know why. We also immediately have an explanation of what gravitational fields are and how masses produce them. In this model, masses actually are gravitational fields of intrinsic spatial velocity. And because masses are a form of spatial velocity, we also now, for the first time, have a simple explanation for why mass and energy are conserved. All forms of energy, including mass, are now recognized as different forms of spatial velocity, and the conservation of mass and energy is simply the conversion of one form of spatial velocity into an equivalent amount of another form of spatial velocity. Very simple and elegant. This model also allows us to formulate a consistent new fundamental principle for relativity, namely that everything in the universe has a total spatial plus temporal velocity equal to c, the speed of light in vacuum. We already know that the velocity in time of objects with linear spatial velocity is reduced, so their total velocity in both space and time is always equal to c. Now, with gravitational fields simply fields of intrinsic spatial velocity, this automatically explains the reduced velocity in time in gravitational fields. Thus, this single principle that the space plus time velocity of everything equals c becomes a single, universal fundamental principle that now explains all aspects of the relativistic universe. So by replacing the old curved space model of relativity with our entirely equivalent intrinsic velocity density model, we gain important new insights into our universe. First, the model is conceptually much simpler because space is now flat as we actually see it, but it still acts the same as it did in the old curved space model. Second, we now, for the first time, have a simple model of what mass actually is that explains precisely how mass creates relativistic space. Third, we now, for the first time, have a simple model that explains how and why mass and energy are conserved, as simply the conversion between equivalent amounts of different forms of spatial velocity. And lastly, a flat space model is easily amenable to a simple computational model of the universe in the form of 3D arrays of velocity-densified space, whereas a curved space model is extremely difficult to reduce to a computational basis. Gravitation. This model also explains gravitational attraction very simply. At every point in a gravitational field, the strength of velocity density is greater towards the center of mass. This produces a velocity vector pointing towards the center of mass that inertial motion tends to follow. This stronger velocity density towards the center of mass is what we feel as gravitational attraction. We need to assume the wavelet vibrations are all the same minimal spatial phase and width, but with amplitudes depending on their gravitational strength. In this way, the vibrations of multiple masses always reinforce each other and never cancel each other out. This neatly explains the additive nature of gravitation and the fact that it can't be shielded. This theory also explains why gravitation appears to be so much weaker than the other forces, for example, electromagnetism. This is because the force of gravitation is due to the minute directional difference in vibrational amplitude at points in the field, whereas the strength of the electromagnetic force on a charged particle is massively stronger because fields of the two charges tend to either completely cancel or reinforce each other at every point. The space-time fabric. In this new model, space is a universal flat fabric, each point of which has a total velocity of c, which is the vector sum of its intrinsic spatial velocity and its local clock time velocity. The presence of intrinsic spatial velocity due to gravitational fields slows the velocity in clock time, so the velocity sum always equals c. So the universal fabric of space is entirely flat, with spherical fields of intrinsic velocity density centered on sources of mass. These velocity density fields are in fact what masses actually are. So everything and every point in this universal space has a single total velocity equal to c, the speed of light in vacuum. This is the velocity at which the universe is continually recomputed, and this c velocity is the ultimate source of time. All this total velocity is in the velocity of local clock time, except where some is in the form of spatial velocity. Thus, any spatial velocity, including the intrinsic spatial velocity of gravitational fields, reduces velocity in time, so the sum always remains equal to c. So in areas of empty space, far from masses and with little intrinsic spatial velocity, the velocity of clock time is very close to c. However, in areas with intrinsic spatial velocity due to gravitational fields, the velocity of time is slowed. Thus, everywhere in the universal fabric of space, there is a total space plus time velocity equal to c. This is the very simple, fundamental structure of the relativistic universe. This new velocity density model of relativistic space is an important advance in our understanding of reality and has many other important implications that are explored in my book, Universal Reality 2.0, and in my other YouTube talks.